In space exploration, man is an integral part of the spacecraft hardware. The human space traveler is able to serve a vital function which could not otherwise be performed. Man can make corrective control adjustments to compensate for certain electronic and mechanical malfunctions occurring within the space vehicle. But what is being done to protect man in this heretofore unknown environment? Bioastronautics personnel in the Air Force Systems Command are well qualified to select, train, conduct extensive research, and coordinate operational medical support in order to ensure man's safety in all manned space exploration. The resources are many, varied, and comprehensive, and are staffed by professionals of the highest scientific competence. Bioastronautics research activities span the continent. At Air Force installations and at universities and private industries sponsored by Air Force contract, professional staffs representing nearly every scientific area are teamed together with one objective: to support and sustain manned space flight. In order to illustrate the broad scope of Air Force bioastronautics research in support of manned space flights, many fundamental aspects of the overall program will be depicted. In addition, applied research associated with the factors involved at launch, during short-duration low orbital missions, during prolonged space travel, and at re-entry will be demonstrated. But before man is exposed to any facet of space exploration, instruments are sent aloft to gather information. Then biological specimens, including animals, are subjected to intensive biomedical space research. Some are launched in these piggyback containers. Many types of animals are used in the various stages of investigation, but chimpanzees are, for the most part, the optimum research animal for spaceflight because of their structural similarity to man and their aptitude for learning performance tasks. In the dry desert climate at Holloman Air Force Base, New Mexico, the Aeromedical Research Laboratory maintains a colony of over 50 primates for training and space environmental testing. In order to be utilized in space exploration, this intelligent animal must be oriented to unusual environmental conditions. Doctors of veterinary medicine, physiologists, electronics engineers, psychologists, and technicians give each chimpanzee childlike care in handling, feeding, and training. Comparative psychologists teach the animal complex performance tasks as part of this training phase. The pre-programmed tests teach the chimp to respond to a specific symbol displayed on the psychomotor display panel. A food pellet or a sip of water is the reward for correct performance. Environmental training, as well as all other phases of bioastronautics research, is under the constant supervision of highly specialized professionals. The chimpanzee precedes man in many phases of space exploration. New concepts of equipment must be tried and tested prior to placing man in the same environment. With this consideration in mind, Lockheed Missile and Space Company, Sunnyvale, California, working under Air Force contract, developed a primate capsule containing a closed environmental system, biomedical instrumentation, and a TV presentation monitoring system. Through successful application of data gained in the chimpanzee program and the concentrated efforts of the many interdisciplinary professions, life scientists are able to further their prime objective, the safety and functionality of the most complex of all missile subsystems, man. Prior to entry into the astronaut training program, The applicant must undergo rigid physiological and psychological acceptance examinations. Data collected in these tests by biomedical personnel are used not only in this evaluation, but are also stored for future reference baseline material. Initial baseline data acquisition is necessary for determining stress parameters or physical limits beyond which a human being could not safely proceed. After examining every aspect of the individual's clinical, physiological, and psychological state, the selectee is trained at the United States Air Force Aerospace Research Pilot School, Edwards Air Force Base, California. The astronaut must have adequate personal equipment which will offer protection during emergencies or when it may become necessary to leave the atmosphere of the capsule for any reason. At the Aerospace Medical Research Laboratories, Wright-Patterson Air Force Base, Ohio, special articles have been fabricated to test equipment. The final result is the creation of protective gear which far exceeds the human tolerance limits to severe external environments. Component parts such as wrist and elbow joints of full pressure suits are evaluated by anthropologists, physiologists, and by psychologists, assuring minimum detriment in human performance while guaranteeing maximum protection. Movement restrictions will be negligible and not hamper the astronaut so that he may instantly cope with any emergency situation. Simultaneous evaluations testing both man and equipment are conducted in many areas of this research and development. Reaction time to stimuli is tested on this computer program input and result analyzer. Personal comfort as well as safety must be examined in the many design and positioning experiments. With assurances of adequate protective clothing, we move now into other areas of continuous experimentation. At launch, there are 4 almost simultaneous occurrences for which the astronaut must have protection: noise, vibration, toxicity, and high forces of gravity. Toxicity data gathered during launch explore the potential hazards of noxious fumes and chemicals on both the astronaut and ground technicians. Records of noise and vibration at stage separation obtained in an actual space flight are used as test limits in laboratory investigations. These noise factors are reproduced in laboratory experiments. The ability to perform is studied during noise exposure tests. High-intensity noise exposure for even short periods of time can become physically intolerable to both support personnel and the astronaut. In addition, space operations require continuous, high-quality communications with the astronaut. Noise as an interfering factor must be reduced or eliminated. Vibration occurs during the high engine performance period at launch and prior to the time orbital velocity is achieved. These vibrations can become so severe as to lead to physical incapacitation. Research is conducted in biomedical laboratories to determine man's tolerance to this occurrence. In addition, training and familiarization programs are designed which tend to reduce the effects of vibration on the astronaut's performance.